Hello friends, in this video we are going to see gate numericals based on Z transformation. Let us begin. Question number 1 is displayed on the screen. It's asked in gate 2014. X of n is minus 1 by 9 to the power n u of n minus of minus 1 by 3 raised to n u of minus n minus 1, then the region of convergence for Z transform is. As we have studied in shortcuts that these are always poles, am I right? So this is pole number 1 and this is pole number 2. Secondly, ROCs are bounded by poles only. So this is going to help me out to find out the region of convergence. Secondly, when it comes to u of n, then if you remember, mod of z will always have a greater relation with respect to the pole. So pole is minus 1 by 9, but radius cannot be negative. So I would say mod of z 1 by 9 for the first signal or a first function. Let's go for the second function. You know that due to presence of u of minus n minus 1, mod of z will have the lesser relation with respect to the pole value. So pole value is minus 1 by 3. We have to take a mod of it, which is 1 by 3. So this is first, this is second. So there are two ROCs. Assuming this is R1, this is R2. So effective ROC is always intersection of R1 and R2 together. So mod of z will be greater than 1 by 9 but less than 1 by 3 is the final ROC. So do we have such option that it is greater than 1 by 9 but less than 1 by 3? That is option C. Is that right? Let's move to the next question. So it is asked in gate 2010. Some transfer function is given h of z and they have given some statements. So first statement says the system is stable as well as causal for ROC mod of z more than 1 by 2 or not causal for mod of z less than 1 by 4, and system is neither stable nor causal for ROC between 1 by 4 to 1 by 2. And which of the following statements are valid? So some combinations in ABCD are given. So first of all, we have to go through those statements, statement 1, statement 2 and statement 3, and we have to see which statement is true, which statement is false. And once I get that, then it is easy to select one of the option out of 4. So traditional way is to solve this h of z. I mean, first of all, the traditional way would be, see, the power is 2, it means it will get factorized into two parts and you will get two poles. Once you get these two poles, then you have to go through the partial fraction, and after going for partial fraction, you can go for finding the constants a and b, and after that we will take inverse Laplace and then we will see the ROC. So this is quite a tedious procedure if you go through a traditional way, but then if you are smart enough, look at the statements. When they are saying mod of z greater than 1 by 2, mod of z less than 1 by 4, or mod of z lying between 1 by 4 and 1 by 2, so indirectly they have already given you the poles. There are two poles. Obviously there are two poles. Why there should be two poles? Because the power of z in the denominator is 2. I hope you are clear with that. So there are two poles. It is 1 by 4 and 1 by 2. Let us concentrate on 1 by 4 and 1 by 2 first. If there are two poles, that is 1 by 4 and 1 by 2, we don't know what are their sign, but at least we know that there will be two circles of radius 1 by 4 and radius 1 by 2. So this is radius 1 by 4 and the radius 1 by 2. And of course there will be one more circle called as a unit circle. See, the reason why I'm considering unit circle, because again they are asking about a stability. Is that right? And whenever you want to see the stability, it should make sure that your ROC must contain unity circle. So if your ROC includes unit circle, then I can say that the system is stable. And if your ROC doesn't include unit circle, then it is unstable. So for my reference, what I'll do is I'll try to get unit circle now. So somewhere over here, there would be a unit circle. Let us see statement number 1, and now we will figure it out whether it is true or false. The system is stable as well as causal for ROC mod of z greater than 1 by 2. So you know that for causality, ROC should be outward. Secondly, for stability, it must include unit circle. Now see to it, if I say that mod of z greater than 1 by 2, it means I'll try to cover this area. See, we will try to cover this area. And if we are trying to cover this area, as you can see that mod of z greater than 1 by 2, then it is including unit circle, therefore it is stable also. Secondly, since ROC is outward, that is outside the outermost circle, therefore I can say that it is causal also. So mod of z greater than 1 by 2 satisfied both the conditions, that system is stable also and causal also. Once again, the reason why I'm saying this is stable, because it is including unit circle inside ROC. And secondly, I'm claiming that it is causal also because ROC is outside the outermost circle, because that's the whole condition for causality. Am I right? So I would declare that statement number 1 is 100% true. There is no doubt about it. Look at S2 statement. The system is stable but not causal for mod of z less than 1 by 4. So let us draw this. They are asking for mod of z less than 1 by 4. We'll try to get this ROC. So we need to deal with three circles: 1 by 4, 1 by 2, and the unit circle. If they are saying mod of z less than 1 by 4, it means this would be the ROC. Am I right? So let us comment on this ROC. First of all, mod of z less than 1 by 4, then the ROC area is inside the innermost circle. Therefore, I can say that this is anti-causal function. So first of all, commenting on the causality, that this is purely anti-causal system. Let us comment on the stability. When it comes to stability, then ROC must include unit circle. As you can see, mod of z is less than 1 by 4. It is covering that area which is inside 1 by 4. So then there is no scope for mod of z less than 1 by 4 to cover unit circle. Therefore, this is 100% unstable. You can say unstable or you can say not stable. Let's see what statement 2 really mean. So statement 2 was related to mod of z less than 1 by 4. Then it says system is stable. So here only I can say that S2 is false, because system is not stable as well as it is not causal. Of course it is not causal, it is anti-causal. Let us check the validity for S3. It says system is neither stable nor causal for ROC lying between 1 by 4 and 1 by 2. Let us draw this. So mod of z is more than 1 by 4 and less than 1 by 2. So let us assume this is 1 by 4 radius circle, this is 1 by 2 radius circle, and there is one more circle for checking the stability that we are drawing for us, that is unit circle. Now the ROC is lying between 1 by 4 and 1 by 2. So between 1 by 4 and 1 by 2, it means the ROC is lying here. Now let us comment on causality of the system. Do you think the system is causal? Of course, system is not causal, am I right? System is not causal because ROC is trapped between two circles, it means it is non-causal. So first of all, it is non-causal. You can say non-causal means it is not causal, because when I say not causal, it can be anti-causal also, it can be non-causal also. But to be very particular, it is non-causal for sure, because whenever ROC is lying between two circle area, then it is non-causal, because it is considered to be a both-sided. It is ROC neither outward nor inward. Next, commenting on the stability, as you can see, since ROC is between 1 by 4 and 1 by 2, there is no scope for ROC to cover unit circle, therefore it is unstable, or I can say it is not stable also. So it is neither causal nor stable, and that was the whole statement of S3. Look at S3. The system is neither stable nor causal. Of course, this is also true. So we can conclude that S1 and S3 statements are true. So option C says it all. That is, both S1 and S3 are true. I'm sure you understood this. So you have to always do, a smart work. You don't have to really follow traditional method every time, even though you know the complete procedure, because it is going to waste your time. And in minimum time, we have to attempt maximum questions, and that's the whole aim of any competitive exam, right? Let's move to the next question. Some x of z is given and ROC is lying between 0 to infinity. If you remember, if ROC is lying between 0 to infinity, it is considered to be a non-causal signal because it is considered to be both-sided, and secondly, it must be a finite length sequence. Am I right? Because whenever it is a finite length sequence, only then mod of z is greater than 0 or mod of z less than infinity or mod of z lying between 0 to infinity, such type of ROCs we get. Otherwise, ROCs are always given in the context of circles. So whenever ROCs are given in terms of circles, that is mod of z greater than 2 or mod of z less than 2, in such cases we always believe that in such cases definitely the given signal consists of infinite sequence. Infinite sequences are those sequences which make use of u of n, u of minus n, or u of minus n minus 1, and so on. So one thing is clear, that definitely the sequence that we are going to obtain would be a finite state sequence. Let's see. X of z is given and they are asking you inverse z transform, that is x of n. Let us handle this. So given x of z is 5z square plus 4z inverse plus 3, and they are asking you inverse z, that is they are asking you for x of n. Am I right? Now we know that time shifting property, if x of n is having z transform as x of z, in that case x of n minus n naught will have its z transform as z to the power minus n naught x of z. Am I right? Similarly, x of n plus n naught will have z transform as z to the power positive n naught x of z. So referring to this, and we should know that del of n has z transform as 1, or I can say that 1 has inverse z transform as del of n. So we should remember this. Next, what I can see here is x of z is equal to 5 z square times, I can take 1 here, plus 4 z inverse times 1 I can take over here, and this is simply 3. Now see to it what I'm doing. When I take inverse z, x of z will become x of n. 5 is constant. Try to understand. Inverse z for 1 is del of n, but this time 1 is multiplied with z square. Now try to understand, if x of z is multiplied by z to the power n naught, then signal becomes x of n plus n naught. Similarly, when z to the power minus n naught is multiplied with x of z, then it is x of n minus n naught. What does that mean? If it is multiplied with z square, it means the signal is advanced by 2. So which signal it is? It is nothing but a delta function. So it is del of n plus 2 plus. I'll keep 4 as it is. Now 1 has inverse z as del of n, but since this is multiplied with z to the power minus n, or here in case it is z to the power minus 1, it will be del of n minus 1 plus, there is only 3 constant, then it will be 3 times del of n. I hope you understood this. If you don't understand, just check over here. If del of n refers to z transform as 1, then del of n minus 1 will have z transform as z to the power minus 1 times x of z, where x of z is what? 1. Or if it is del of n plus 2, then the z transform will be z square times x of z, but x of z is equal to what? 1. So please understand, when I have only z square, its inverse z is del of n plus 2. When I have only z inverse, then its inverse z is nothing but del of n minus 1. And when I have only 1, then its inverse z is del of n. I hope now you have understood what we had over here is z square, then z square will be del of n plus 2 as inverse z. Z inverse will be del of n minus 1, and only 3 means if nothing is there, then there is 1, and 1 has inverse z as del of n. So in a way, x of n is equal to 5 times del of n plus 2 plus 4 times del of n minus 1 plus 3 times del of n. So here option A is the correct option. I'm sure you understood how to handle this. In fact, if this is the answer, you can also write it in sequence form. We have learned this. Del of n is always present at n equal to 0. So at n equal to 0, the magnitude is 3. Then if they are saying del of n minus 1, we know that impulse signal, when I say del of n minus 1, it is present at n equal to positive 1. So at n equal to positive 1, it has got magnitude as 4. Secondly, we have del of n plus 2. Please understand, del of n plus 2 means impulse function present at n equal to minus 2. So when I say n equal to minus 2, it means n equal to minus 1 sample is missing here. So it will have 0. And at n equal to minus 2, it has magnitude as 5. Then this is the actual sequence of x of n. So we have learned that when x of n is given in sequence form, how to express it in terms of delta function, and if it is given in shifted impulse form, then how to express that into sequence form, and vice versa also. If the sequence form is given, how to get it in terms of shifted impulses. So I'm sure you got this problem. Let's move to the next problem. It says z transform of the sequence x of n is given by, and some x of z is given with region of convergence mod of z more than 2. So as you can see from this, it is clear that this must be a causal sequence. Am I right? So please understand, after taking inverse z, you have to multiply either with u of n, or you may have to multiply with minus of u of minus n minus 1. And how do you decide that? Of course, you decide whether it is causal or anti-causal. In case if it is causal, then you have to multiply with u of n, and if it is anti-causal, then you have to multiply with minus of u of minus n minus 1. So here what they want is x of 2. What is meant by x of 2? That they are asking you to find x of n, and then they are asking you to substitute n equal to 2. In that case, what you will get is x of 2. So what they want is x of 2. So if I'm able to get x of n, that is some mathematical expression of inverse z of x of z, then it becomes easy for me to get x of 2, and that's the only way to calculate x of 2. So let us take x of z, what they have given, which is 1 upon 1 minus 2z inverse the whole square. If you have watched all the videos, then you should understand that it is somehow equivalent to a standard term as az upon z minus a square. So this is quite analogous to a term called as z upon z minus a square. How it is equivalent? I'll make it equivalent. Just wait. So what I'm doing is, if I'm multiplying and divide by z square, then I'll get similar form. Am I right? So somehow I should remember that this is the form that we have, or let me just handle it the other way around. So just forget that we have discussed something here. X of z that they have given is 1 upon 1 minus 2z inverse the whole square. Am I right? Now let me remind you the formula that we have learned in last video lecture. What that formula says, it is n times a to the power n u of n has z transform as az upon z minus a whole square. So this is the form that we have. This is the standard form. This is the standard formula do we know. Now what I want to do, that I want to mold this into this. Am I right? I want to mold this into the given expression. So what I'll do over here is, first of all, I'll rewrite this as az upon. Now since it is in the terms of z inverse, so I'll take z square out. So if I take z square out, what remains inside is 1 minus az inverse whole square. Here this z and z gets cancelled. So what is remaining that we have, let me just write it. N a to the power n u of n is now equal to a upon z into 1 minus az inverse whole square. Is that right? This is what we have right now, and what is given in the question. So I'll write it over here so that you can compare. Okay, so what they have given is 1 upon 1 minus 2z inverse whole square. So it mostly looks like this only. Am I right? So what I'll do is, see, Now somehow, as I said, that I have to compare these two. Somehow I want to convert this star marked expression into above expression. So if you see that in above expression the numerator is 1 and here numerator is a, so let me shift that a to left hand side. So what I'll get is n into a to the power n u of n whole divided by a, and now this is equal to 1 upon z into 1 minus a z inverse square. Is that right? Now still if you compare the value of a over here, it is 2. So let substitute a value equal to 2. So what I'll get on left hand side is n into 2 to the power n upon 2 u of n has a z transform as 1 upon z into 1 minus a z inverse. In fact, a is equal to 2 now. So it is 2 z inverse whole square. I hope you are clear with that. Now let me tell you the problem. Somehow I managed to get in above expression. So this is the term I'm looking for, right? Now this term is present over here. Can you see what is the extra thing present? Extra thing present is z. But let me tell you, you cannot transfer this z to left hand side. So only those terms you can shift it from left to right or right to left. That is from time domain to frequency domain or frequency domain to time domain is only constant part. But you cannot transfer the independent variable. Therefore, somehow what I'll do is I'll use one concept. For example, now try to understand this. Suppose if I have x of n whose z transform is x of z, then just let me know what if I have z times x of z. Then we know that since z power is positive 1, it means input must have advanced by 1. So it will become x of n plus 1. Same thing I'm trying to do over here. Just pay attention. Suppose if I consider this highlighted thing is x of z, and if I consider this whole thing as x of n, right? Now what I'm trying to do is I want only x of z here. So I have to multiply by z. So whenever I multiply some x of z with z, then only this z and z will get cancelled. Am I right? But then if I'm multiplying by z, what should happen in the left hand side? In left hand side, there has to be advance by 1 unit. Is that right? So what I'll do over here, so let me restore what I had over here. See, this is what we have as x of z. Am I right? This is x of n, this is x of z. So what I'm doing, I don't want this z. If I don't want this z, I need to multiply z with x of z, and only then what will happen, this z and z will get cancelled. But then if you want this z to get multiplied with your original x of z, then you must advance your input signal x of n with 1. So let us advance the input signal with 1. So x of n will become x of n plus 1 if you multiply z with x of z. I hope you understood our motive to multiply x of z with z. Then on left hand side what will happen? So on left hand side, when I say x of n it's some expression, then x of n plus 1 means replace n with n plus 1. So wherever you have n, replace n with n plus 1. So on left hand side what we will have is n plus 1, 2 raised to n plus 1 whole divided by 2 u of n plus 1, and its z transform is, since I have multiplied with z, now this z and z gets cancelled. What is remaining is 1 upon 1 minus 2z inverse the whole square. And you know what? I was actually looking for inverse z for this term only. So it is ready. So this is your x of n now. So since this is your x of n, you have to get x of n at n equal to 2. Please recall the question. You wanted to have x of n, then you had to substitute n equal to 2, and that is x of 2. Let's try to get x of 2 here. So substitute n equal to 2. If I do so, it will be 2 plus 1 multiplied by 2 raised to 2 plus 1 is 2 cube divided by 2, and u of n plus 1 at n equal to 2. Please understand, you cannot substitute n equal to 2 here. Whenever there is a step function, you have to calculate u of n plus 1 at n equal to 2. You know that what is u of n plus 1? U of n plus 1 is a step signal starting from minus 1. it is present from -1 up to infinity. So for n equal to -1 it is 1, at n equal to 0 it is 1, at n equal to 1 it is 1. I hope you are trying to get what I'm trying to tell you. So u of n plus 1 is something which will start with -1, 0, 1, 2, 3 and so on. It is having continuous amplitude as 1. So just check, this is u of n plus 1, the function that I have drawn over here. At n equal to 2, what is the value? At n equal to 1, as you can see, the value is 1. Let us substitute. So this 2 plus 1 has become 3. This 2 and 2 gets cancelled here. And u of n plus 1 value is 1. So this comes out to be 12. Then 12 is the answer. So x of n at n equal to 2, it is 12. Let's move to the next question. Before I proceed with the next question, I can actually solve this question by the other way around. See how? The x of z which was given to you, I'll write it. It is 1 upon 1 minus 2z inverse whole square. Can I just make it two different functions, like 1 divided by 1 minus 2z inverse multiplied by 1 upon 1 minus 2z inverse. I hope you got the point. This is what I'm claiming as x of z. Can I say that this is x1 of z and this is x2 of z? Tell me, multiplication in frequency domain, then there is convolution in time domain. Then here I get x of n after z inverse. So I'm taking z inverse on both the sides. We know this is a standard expression. 1 upon 1 minus 2 z inverse is 2 to the power n u of n. Multiplication in frequency domain becomes convolution in time domain, and this is also same function, 2 to the power n u of n. 2 to the power n, 2 to the power n, I'll take common. What remains inside is u of n convolved with u of n, and u of n convolved with u of n is n plus 1 times u of n. Am I right? This is your x of n finally. And you had to calculate x of n at n equal to 2. So x of 2 is equal to 2 to the power 2, 2 plus 1, then u of n at n value equal to 2. You know that u of n is continuously 1 from n equal to 0 to infinity. So even at n equal to 2, u of n value is 1. And again, x of 2, if you calculate, it is 12. So I keep telling students that if you know the concepts, then there are infinity solutions. Or to be very precise, there are many solutions and you have to select the easiest one, right? The next question, x1 of n and x2 of n is given for n equal to 0 and n equal to 1. Naturally, the arrow marks would be present here. Z transform for convolved sequence x1 of n convolved with x2 of n. So x1 of n is given, which is 1 comma 1. I can write x1 of z directly. It is 1 plus z inverse. Am I right? How do we get that? We know that since there are only two symbols, it will be from n equal to 0 to 1, x of n z to the power minus n. So this can be expanded as x of 0 z to the power 0, x of 1 z to the power minus 1. So what is the value of x of 0? It is 1. Z to the power 0 is 1. X of 1 value is also 1. Z inverse. Then this is equal to 1 plus z inverse. So this is what I'm saying, that x1 of z can be written directly. Similarly, I can write for x2 of z also. So x2 of z is 1 plus 2z inverse. The reason why I have taken z transform, because the answers are in terms of z only. Am I right? So you know that convolution in time domain becomes multiplication in frequency domain. So after multiplication, you will get 1 plus 2z inverse plus z inverse plus 2z to the power minus 2. And finally, I can write 1 plus, you can club these two, and then it will become 3 times z inverse plus 2 times z to the power minus 2. And refer the options, it is option C. So it was very simple question, very straightforward question. You had x1 of n, you had x2 of n. They are asking you z transform of convolution of x1 of n and x2 of n. So instead of performing convolution, I preferred that I'll do multiplication in frequency domain. And also, since signals are smaller and plus it is discrete in nature, you can go for a table method. By using a table method, convolve x1 of n, x2 of n together and get x of z directly. I'll do it for you. So I'll prefer method 2 now. So x1 of n, it is 1 comma 1, and x2 of n, it is given as 1 comma 2. Let me confirm it. Yes. Let us have convolution. So convolution, we use a table method. So this is for x1 of n, and this is what I'm writing for x2 of n. Let us have multiplication. 1 into 1 is 1, 1 into 1 is 1, 2 into 1 is 2, 2 into 1 is 2, and then we make those partitions. So first element after convolution is 1, next is 2 plus 1, which is 3, and last is 2. So 1 comma 3 comma 2 is the output for convolution with arrow mark at 1. So this is the convolution of x1 of n convolved with x2 of n. But we want it in z transform form. So what I'll do is, I'll take z transform for this. We know how to take z transform. So first term would be 1 only, plus 3 times z to the power minus 1. You know that this is x of 1, plus 2 times z to the power minus 2. You know this is x of 2. And as you can see, you are still getting the same option, right? Let's move to the next question. So y of n is given where x of n convolved with h of n is y of n. Convolution is performed between x of n and h of n. It is given that z transform for y of n, that is y of z, they have given, and they are asking you z transform for p of n where x of n convolved with h of n minus 2. Let us try to understand the question. I'll make you understand what the question is about. Y of n is equal to x of n convolved with h of n, and y of z is something that they have already given. Is that right? Then what they are asking you is z transform for p of n where p of n is x of n convolved with h of n minus 2. So they have given p of n which is equal to x of n convolved with h of n minus 2. Am I right? They are asking you p of z. Let us take z transform on both the sides. P of n will become p of z. X of n naturally becomes x of z. Convolution in time becomes multiplication in frequency domain. And if I say h of n has z transform as h of z, then by using time shift property, it will be z to the power minus 2 times h of z. Is that right? Then what I'll do is I'll take z to the power minus 2 one side and I'll multiply x of z with h of z. So we know that x of z into h of z is what? It is y of z. This is y of z. How come? Because we know that x of n convolved with h of n is your y of n, or I would say y of z is equal to x of z multiplied by h of z. So x of z multiplied by h of z is y of z itself. So z to the power minus 2, y of z they have already provided, it is 2 plus 3 z to the power minus 1 plus z to the power minus 2. Let us expand this. You'll get 2z to the power minus 2 plus 3 to the power z to the power minus 3 plus z to the power minus 4. And if you see carefully, it is option D. So what they were asking you for p of z and now we have P of Z with us. Is that right? Let us start with the last problem. The input output relation of causal stable LTI system is given as, and they have given some relation between y of n and x of n. If the impulse response h of n for this system satisfies the condition, so this is impulse response condition they have given, and now they are asking you relation between alpha and beta. As you can see, alpha and beta are defined while relating output with input. Let us try to solve this problem. So let me copy the relation between y of n and x of n that they have given already. So y of n, they have said it is equal to alpha times y of n minus 1 plus beta times x of n. Taking z transform on both the sides, you'll get y of z, which is equal to alpha times, use a time shift property, it would be z inverse times y of z plus beta times x of n will become x of z. Is that right? Now what I can do is I can shift this y of z term here, and if I take y of z common, what remains inside? 1 minus alpha z inverse, this is equal to beta times x of z, or I can say h of z, which is nothing but a ratio of y of z upon x of z, known as a transfer function. Now this is equal to beta upon 1 minus alpha z inverse. This is your h of z. Is that right? Now from this h of z, if I take inverse z, then I'll get what? H of n. This is equal to, I'll consider beta as constant, and you know that if it is 1 upon 1 minus a z inverse, then it is equal to a to the power n u of n. So using the same concept, what I can write over here is alpha to the power n u of n. This is h of n, what I can write. And now they have given us something, that is summation from n equal to 0 to infinity h of n, they have already given to us. So you know what, this is also h of n. So let me take summation from n equal to 0 to infinity, and let me write the expression of h of n that I have. It is beta times alpha to the power n u of n. Am I right? So this value of summation of h of n, they have already provided us as 2, and here let us substitute n equal to 0 to infinity. So when I substitute n equal to 0, alpha to the power 0 will become 1, and therefore it will become beta times 1 plus beta times alpha plus beta times alpha square, and so on. This will go up to infinity. So if I take beta common, what remains inside is 1 plus alpha square, and so on up to infinity. So I'll use the concept of GP series. So this beta times, so I'll approximate this as 1 upon 1 minus first term or common term, that is 1 upon 1 minus alpha, and this is equal to what? 2. Or I can say beta equal to 2 times 1 minus alpha, and by rearranging the term you'll get alpha equal to 1 minus beta by 2, and this is the relation between alpha and beta that they were asking you for. And check kindly, it is option A. I'm sure you have understood all the problems. So you have to first of all see all the video lectures carefully, make your own notes, keep practicing, especially all properties of Z transform. And once you are comfortable with all the rules, all the properties, then only it becomes easy for you to crack such problems. Thank you.